Hello everyone. Today's lecture is based on the applications of geomatics engineering. So, this lecture will give you overall view what are the different areas where we can apply the data which we have collected from the various tools using the our knowledge of geomatics engineering. So, there are various applications of geomatics engineering and we can see here that the list given is quite long, but this is, let me share with you, this is the exemplary list. The applications are much more beyond this particular list, and in this list you will find that it is not only limited to civil engineering. You can see there are a lot of applications, like if I talk about the agriculture part, if I talk about the public health, I talk about the meteorology, climatic change, oceanography, business, crime mapping, telecommunication, military. So, there are very large number of applications which are non-civil engineering applications. So, in other words, I would say that this has become a multidisciplinary area wherever earth surface data is required, wherever the project deals with the coordinate systems, we can use our knowledge of geomatics engineering, collect the data and use the data in our project. The Government of India is also using the geospatial tools or geomatics engineering in large number of projects. You can see whether it is a digital India project, or it is the smart city concept, or maybe in the national afforestation program, national mission for clean Ganga, or northeastern regional urban development program, Delhi Mumbai industrial corridor. Geomatics tools, either in the form of the satellite image or GPS or drone survey or GIS, they are contributing a lot for the successful commissioning and successful completion of the project. So, in larger projects now, it has become very essential to use these tools and provide the input so that the project is successfully completed. If we talk about the GPS survey, GPS is a worldwide radio navigation system which basically will determine the exact location where you are standing with the device. So, this is known as global positioning system. So, that means anywhere on the globe you stand with this device, it will provide you the data 24 hours a day. So, basically it is working on the concept anywhere, anytime. So, anywhere you stand on the globe, anytime you want the data, you can collect the information from this device. So, this has reduced our data collection time, because earlier our instruments were working in the daytime only. We were not able to use them during the night hours. But here, using the capability of the GPS, we can take 24 hours of observations anywhere on the world. So, you are getting very precise data in terms of the coordinates x, y and z, and also you are getting the very precise time. In fact, in engineering survey we do not require the time data. Time data is required for military and defense applications. So, we are using the capabilities of the coordinates also, the 3-dimensional coordinates which we are getting from the GPS, we are using them for engineering, mapping and monitoring purpose. So, here you can see that it is a handheld device which is being used by the observer in the field. So, very simple to use. You take this device in the field, put it in your hand and start collecting the data. So, simple to use and in fact pretty good. You know, if you want some meter accuracy, this can give you that accuracy, and there are many projects. Suppose I have a road or railway alignment for 60 kilometer, then maybe that this crude GPS, the handheld GPS, maybe it will give you good data for planning purpose. But there are projects where we require very high accuracy. There we have to go for geodetic, a different kind of GPS, so that we get highly accurate data. So, here you are getting latitude, longitude and altitude of the place of the point where you are standing with this GPS devices. So, you should have a clear visibility to the sky, that is the only condition when you are using this instrument. So, if we look at the applications part, whether it is a road construction, putting on a dozer, whether it is the digging part of the earth, whether we are monitoring the bridge deflection, whether we are doing the alignment survey, or many of the dams, the cracks are developing or their deformation is taking place. So, we can measure those precise measurements with the help of the GPS. Once we know the coordinates at one time and we monitor them, we can determine that. So, these are used in various engineering applications. The second instrument is ground penetrating radar instruments. So, here these instruments will provide you high resolution coverage of the area. So, you can see this instrument, it has actually a trolley. This is the trolley where the instrument is mounted. This is the actual device, antenna and transmitter, and we have a control unit on the top of the instrument trolley. So, there is a handle actually to move this instrument, and there is a control unit where you can get the display device. The instrument you are keeping basically the face down. So, when you are keeping the instrument face down, it transmits the radio waves that penetrates into the ground, and it gives you the signal what is below the ground. So, it does not give you the image, but it will give you the signals, the reflected radiations which will be recorded by these devices, and those radiations are to be interpreted. So, if we look at further that how this instrument is being used on the ground, this is the face down of the instrument, and it has to be moved by a person physically on the ground. So, it is providing us the different pattern, reflectance pattern of the radar beams which are reflected from the objects which are below, and we can interpret them and find out whether it is a pipeline or it is a cable line or it is some buried structure using the pattern. So, this is a very very popular non-destructive method of investigation. Otherwise, our earlier methods were based on trial and error and dig method. You have to dig a hole and see whether the pipeline is available or not, but we can be very precise with the help of this device nowadays, because it can pinpoint the exact locations. This ground penetrating radar is available along with the GPS. So, we get the coordinates also of the point where the curve is different in nature. So, this is a very useful to determine the underground utility. Nowadays, when we are talking of the smart city, in fact, all our utilities are to be buried under the ground. So, most of the utilities are along the roadsides, and you must have seen that whenever there is a maintenance or new facilities are to be commissioned, then the road is damaged. So, in fact, that can be minimized with the help of this ground penetrating radar device. And what happens here is that the person is moving the instrument in the field here, and these radar beams are transmitted to the ground, and then there is a receiver. So, this is transmitted to the ground, and then whenever there is a change in the strata or there is a drainage pipe observed, the radar beam will reflect back, and this is recorded by the device. So, there is a receiver device, there is a transmitter device fitted here, and that will record the reflected radiations which are coming from the object. And these reflected radiations which are coming from the drainage would be different than which are coming from the soil layer. There are three types of soil layers which are shown in the diagram: soil layer 1, 2 and 3. So, the reflectance will actually come will be received from all these strata, and then we have to carry out the interpretation of the data in order to determine what kind of objects could be present below the ground. This has application in very large number of fields. It could be the hydrogeological investigations, if we have to map the bedrock below the ground, if we have to understand the water level below the ground. So, this can give you the clue about that. If you want to evaluate the engineering investigation of the dam site, tunnel, pavements, roadbeds, etc., that can be done. As far as the buried structures are concerned, very useful for location and evaluation of the buried structures, because we can't see them from the surface, but we can definitely identify from the reflectance pattern. If there are cavities below the ground, if there are tombs, there are archaeological artifacts or animal burrows. So, they are all very easily located with the help of the GPR observations. So, very useful for subsurface mapping of the cable, pipeline, water lines, etc. So, it has become almost mandatory in a smart city that all our utilities will be buried under the ground. So, this GPR instrument has become quite popular in doing that underground utility mapping, because one has to keep the record of the underground utility mapping in case the expansion is required, in case the maintenance is required or repair is required, then you need a very accurate map. So, the rays can penetrate to a certain depth, and it will depend upon the frequency of the antenna which is being used. As you can see here, if you require very high resolution data, you have to use high frequency, and if you require very deep penetration, you have to use low frequency antenna. So, I want 20 meter or 30 meter deep penetration and would like to know what is below the ground, then we have to use for low frequency antenna. In fact, the low frequency antennas are expensive as compared to the high frequency antennas, and it depends upon the depth also, which depth measurements, whether we want up to 3 meter depth measurements below the ground or not. The next application is for the terrestrial laser scanner. So, we have airborne laser scanner and terrestrial laser scanner. It is mounted on the tripod on the ground, and very useful device whenever we want to carry out the elevation mapping. For example, the bridge. So, we want to actually do the mapping of the entire bridge and find out the deflection in the bridge when there is a heavy load passing on this particular bridge. We want to carry out the building facade mapping. So, we can do that. If there is a tall structure and we have to monitor that structure, or maybe the inclination of that or the deformation in the dam, then the terrestrial laser scanner are very good devices. So, these devices basically are working on the principle of the laser beam and record very dense data, 3-dimensional data, x, y and z data would be recorded for the objects. Your objects could be dam site, it could be bridge, it could be tower or any structure whom we want to monitor. So, once you are collecting this 3D dense data with the help of the device, which is almost automatic, because you have to define the extent and then the scanning will be done automatically. So, it will scan the whole of the structure in automatic manner and will provide you point cloud 3-dimensional data, and from that point cloud 3-dimensional data you can recreate the geometry of that figure, you can create a 3D model of that particular figure and carry out very precise measurements. So, measurements in terms of the depth, measurements in terms of the volume, that also can be carried out. You can see from the figure on the right, there is a bridge here, and the bridge pillars and deck can be very clearly seen, and the bottom one is a picture of the long building. So, there is a long building and which has been scanned by these devices, and then the top view. So, this top view basically is showing you the data which has been created in the computer. So, whenever we are talking of the visualization, we are talking of the virtual reality, these instruments are providing very good input data to our that. There are many structures where deformation is taking place, or sometimes there is a sinking which is taking place in the high rise buildings or maybe the dam site, or there is an inclination from the vertical, the transmission towers, or cracks are being developed on the surface. So, that minute observations which are not visible to our normal eye, we can do the monitoring with the help of the terrestrial laser scanner, and the coordinate systems which we have measured at different times will give the information about the deformation or about the changes on the surface of the structure. Mobile mapping system is very useful when the area covered is very large. So, when the area covered is very large, maybe we cannot use a laser scanner, it is heavy, transportation will be difficult, and moving from one place to another you cannot cover a large area. So, the advancement in the technology is that we mount these devices on a special kind of a vehicle. This is a vehicle specially designed for collecting the data while the vehicle is moving. The instruments are automatic in nature and they will keep on collecting the data. On the top of this vehicle, you can see the instruments are mounted, and when this vehicle is moving in the normal crowd, as you are moving a normal vehicle, the instruments are digital, they are automatic. So, they keep on collecting the data of the area in which you are moving the vehicle. If you look at the top of this vehicle, you have the GPS antennas. So, you need the coordinates of the points where you are collecting the data. Then you have the digital camera also. So, it will take the pictures of the area. You have two digital cameras, with the overlap you can create a 3D model of the area. Then you have the laser scanner, and laser scanner will give you point cloud data. So, you are getting lot of data collected by simply moving the vehicle on the road. And also on the right side, now you can see the change in the technology. There is a 360-degree camera, which is a new concept came in surveying. Earlier, we are aligning the camera in one direction and taking the image. When I take the image in the other direction, I have to move my camera, align the camera in the other direction. If I want to take the image backward, then I have to actually align the camera backward. But with the help of this 360-degree camera, it will give you the panoramic view all around. So, when the vehicle is moving on the road, on all four sides of the road, the front view, the back view, the side views, they are all captured by this 360-degree camera. So, this is a new concept which is coming, where just from one particular point you can collect a very large number of images all around you, and then you can create a panoramic view, or if you want to study in 3D mode, you can study particular feature in the 3D mode. So, these have lots of applications whenever we are talking of a large area. If the large area of the terrain is to be mapped, physically it is not possible to carry the instrument. So, mount everything on the device, on the mobile system, and move it and collect the data. So, if we have to widen a road, for example, and my road is 60 km long, so this system can very quickly collect the data. You move along the road in the normal crowd, collect the data, and then use this data for widening the road or maybe design of a new road. So, you can see in this particular slide also the recreation of the bridge. So, the data has been collected for the bridge and the model has been created in the computer environment. This is the building facade. So the facade mapping with the help of this device has been done. So this is very, very useful, particularly for large area inaccessible areas, because this will collect the data from a distance. So maybe there are problems, the area is not accessible, you cannot go with the instruments, the area is snow covered, or there is a large water body, we cannot go there. So from a distance you can cover a very, very large area. So in accessible area it is very useful. It can reduce our time of data collection, it will provide us very precise data, and 360-degree panoramic view we can get with the data. So all the data can be used for a normal mapping, or you can create a 3D model and then subsequently used in the analysis work. But if our area is further large, huge area is there, then maybe the survey with a vehicle again is not possible. Then we have to use our laser based device, we mount in the aircraft, and aircraft will cover a very large area in the shortest possible time. So when we are moving with the aircraft, we are mounting here the GPS, which will give me the coordinate systems, and this will roll IMU will give me about the X, Y, and Z, the rotational elements of the aircraft, and also I have the device which is fitted over here, the laser device, which will collect the data for a large number of points from the space. So you see in this particularly next slide, you can see that the aircraft is collecting very, very large number of points in the ground. So very large number of points in the shortest possible time can be collected. In fact, this technology was developed, lidar technology was developed in 1960, but it was somehow not appreciated at that time and not used in the surveying, but it is now getting popular, and for large number of applications, when the area is used, you can get X, Y, Z data in the shortest possible time. So when you are getting X, Y, and Z data, you can create 2-dimensional map, you can create 3-dimensional map, which are required for many engineering projects. You can accurately depict the topography of the ground. So again, very, very useful for areas which are inaccessible, difficult to go physically on the ground. So this lidar technology can give us 10 to 15 centimeter height accuracy, 30 centimeter to 60 centimeter the planimetric accuracy, and then it will cover a very, very large area in the shortest possible time. As an example, 300 square kilometer area in 1 hour, which is by other means it is not possible. The other advantage of this is again day and night working. So you can collect the data during the day and during the night time. So your productivity becomes almost double also by using this day and night approach. So this is a very, very useful tool, and this example shows there for a piece of land the lidar data has been collected, and this is in fact the million of points what you see in the area. So these are the tree canopies where the data has been collected using the airborne lidar survey, and green are those tree biomass in the area, and the white areas what we see on the slide here, this is all the river area or non-forested area, sandy area, and there are certain rivers also in the area which are flowing through that. So if I zoom this area, because this is a dense data, so you can see it at a full resolution. So when you start zooming this particular data, you can see now the height of the trees, so individual height of the trees, and you can see the dry rivers also very clearly now in this particular scene, and further enhancing this, further enlarging, now you can count each and every tree. So for example, the biomass estimations, this is very useful. You want to find out the height of the tree, you want to find out the species of the tree, or you want to find out the areas which could be used for afforestation program. So very easily one can do with that kind of a resolution data which is available to us. In civil engineering projects, No more we are doing planning in the 2D environment. Earlier we were using topographical maps which were 2D representation of the 3D earth. But nowadays we are using digital elevation model. So this is one example where digital elevation model has been created from the lidar data. When you are creating this elevation model, now you can understand the topography of the ground very well, because with your normal eye you can see the peaks on the ground. Here also you can feel the peaks, you see the valley area, here also you can see the valley area. So ups and downs in the areas you can visualize, and you can now design your project, or commission your project in the 3D environment using the capabilities of the digital elevation model. We use satellite images. Now there are various kinds of satellite images, from the medium resolutions to coarser resolutions to very high resolution satellite data are available to us, where we can extract the information depending upon our requirement. So you can see that there are large number of satellite. This is just the exemplary list. Landsat is American, IRS is an Indian satellite, Spot is a French satellite. Like that, we have large number of satellite images available from various satellites. So depending upon the requirement, we can select the resolution, we can select the kind of a data. This shows that how the high resolution satellite images are not only used for mapping purpose, but administration is using for activity like Mahakumbh, management of the Mahakumbh. This is Allahabad area. You can see the Sangam area in the middle here, and these high resolution satellite images are used by administration. This is a tsunami where pre-tsunami is on the left and the post-tsunami is on the right. One can carry out the damage kind of a assessment using these images. When we are using the coarser resolution images, we can use for disaster management. So this is a hurricane in 1992, and one can see the movement of the hurricane towards the land area. So we can give advanced warning. So we can develop kind of advanced warning system for that. Land use map is very important for any planning activity on the land surface. So what I am showing you here is a satellite image, and ultimately you are going to prepare a land use map. That means what are the different features, how much is the forest area, how much is the water. The green here is the forest area and the blue here is the water areas. So you can carry out actually the correct estimation of the land and use the land for the specific purpose. The next one is the drone, unmanned aerial vehicle, and you are collecting the data for very large scale mapping data. If it is required, then you can collect this data for various applications, whether we are talking of agriculture application, whether we want to identify the different minerals, or we want to find out the organic matter into the soil. So the list is quite long, as you can see in this particular slide, that the UAV and the drone data has been used in parcel delivery, in insurance claims, in wildlife monitoring, in land surveying, in agriculture, in construction activity. So there are several activities which are non-civil engineering, outside the domain of non-civil engineering. There also the drone is playing very important role. Then the entire data set is integrated into the GIS, and GIS not only will integrate the data, but will be useful to develop as an expert system or a decision support system. So the advantage of the expert system and decision support system is that we can quickly change our input parameter and get the best results and get the best output from the GIS, and then it can help us in taking a good decision, best decision for the project work. So we can use the capabilities of the GIS to integrate, to analyze the data, to make the query system from this database. Now, there are very large number of applications of the GIS also. The list is very long, as you can see on the periphery. It is from land management to watershed analysis to sea surface analysis, topographic analysis, resource analysis. So, there are very large number of applications of the GIS also which could be used. Now, there are 9 areas which have been identified where geospatial technology is going to impact the normal people, going to play very important role in the life of the normal people. These are the infrastructure, transportation, housing, environment, public health, emergency response system, retail system and the finance system. So, these are the future areas where these geospatial technology have a great role to play. Now, here in the last slide, what I want to say is that there are various ways of collecting the data from aerial photographs, from lidar technology, satellite image, GPS, from UAV systems. So, the collection of the data and providing the real time information about the activity, about the happening on the land surface is really something very challenging, and we have to learn that, so that we can use the data which we have collected and the tools for our better planning and decision making for various projects. So, thank you very much.